Hi everyone, in this video we will talk about multiclass classification. Whereas binary classifiers distinguish between two classes, multiclass classifiers, also called multinomial classifier, can distinguish between more than two classes. Some algorithms such as random forest classifier or naive Bayes classifiers are capable of handling multiple classes directly. Others, such as support vector machine classifiers or linear classifiers, are strictly binary classifiers. However, there are various strategies that you can use to perform multiclass classification using multiple binary classifiers. For example, one way to create a system that can classify the digit images into 10 classes from 0 to 9 is to train 10 binary classifiers. One for each digit, 0 detector, 1 detector, 2 detector, and so on. Then when you want to classify an image, you get the decision scores from each classifier for that image, and you select the class whose classifier outputs the highest score. This is called the one versus all OVA strategy, also called one versus the rest. Another strategy is to train a binary classifier for every pair of digits. One to distinguish zeros and ones, another to distinguish zeros and twos, another for ones and twos, and so on. This is called one versus one OVO strategy. If there are n classes, you need to train n product with n-1 divided by 2 classifiers. For the mnest problem, this means training 45 binary classifiers. When you want to classify an image, you have to run the image through all 45 classifiers and see which class wins the most duels. The main advantage of OVO is that each classifier only needs to be trained on the part of the training set for the two classes that it must distinguish. Some algorithms, such as support vector machine classifier, scale poorly with the size of a training set. So for these algorithms, OVO is preferred since it is faster to train many classifiers on small training sets than training a few classifiers on large training sets. For most binary classification algorithms, however, OVA is preferred. Scikit-learn detects when you try to use a binary classification algorithm for a multi-class classification task, and it automatically runs OVA except for SVM classifiers, for which it uses OVO. Let's try this with SGD classifier. SGD classifier object dot fit open parenthesis x underscore train, comma, y underscore train, close parenthesis. SGD classifier dot prediction sum digits. The result equal to 5. That was easy. This code returns the SGD classifiers on the training set using the original target classes from 0 to 9. Then it makes a prediction, a correct one in this case. Under the hood, scikit-learn actually trained 10 binary classifiers, got their decision scores from the image, and select the class with the highest score. To see this is indeed the case, you can call the decision function method. Instead of returning just one score per instance, it now returns 10 scores, one per class. Sum digit scores variable equal to SGD classifier object dot decision function sum digit. Sum digit scores equal to, this is the result, which is 10 scores. The highest score is indeed the one corresponding to class 5. mp.argument maximum sum digit scores, the result equal to 5. SGD classifier dot classes, the result equal to this, 0, 1, 2, 3, 4 to 9. LGD classifier object dot classes index 5, the result equal to 5. When a classifier is trained, it stores the list of target classes in its classes attributes, ordered by value. In this case, the index of each class in the classes array conveniently matches the class itself. For example, the class at index 5 happens to be class 5, but in general you won't be so lucky. If you want to force scikit-learn to use 1 versus 1 or 1 versus all, you can use the 1 vs 1 classifier or 1 vs raised classifier classes. Simply create an instance and pass a binary classifier to its constructor. For example, this code creates a multi-class classifier using the OVO strategy based on SGD classifier. From scikit-learn.multiclass import 1 vs 1 classifier class. OVO classifier object equal to 1 vs 1 classifier, open parenthesis, SGD classifier. This is a hyperparameter of SGD classifier class, like maximum iteration equal to 5 and another parameter, close parenthesis, OVO underscore classifier object dot fit, open parenthesis, x underscore train, comma, y underscore train, close parenthesis, OVO classifier dot prediction of some digit. The result equal to 5. To train a random forest classifier is just as easy. Forest underscore classifier object dot fit x underscore train, comma, y underscore train, close parenthesis. Forest classifier dot prediction some digit, the result equal to 5, which is the class of this image. This time scikit-learn didn't have to run OVA or OVO because random forest classifiers can directly classify instances into multiple classes. You can call predict or prediction probability to get the list of probabilities that the classifier assigned to each instance for each class. Forest classifier object dot prediction underscore probability of some digits. The result equal to 0.1, 0, 0, like this. You can see that the classifier is fairly confident about its prediction. The 0.8 at the fifth index in the array means that the model estimates at 80% probability that the image represents a 5. It also thinks that the image could instead be a 0 or a 3, 10% chance each. Now, of course, you want to evaluate these classifiers. As usual, you want to use a cross-validation. Let's evaluate the SGD classifier's accuracy using cross-validation score function. Cross-validation score, open parenthesis, SGD classifier object, comma, y or x underscore train, comma, y underscore train, comma, CV equal to 3, scoring equal to accuracy, close parenthesis. It gets over 84% on all tests faults. If you used a random classifier, you would get a 10% accuracy. So this is not such a bad score, but you can still do much better. For example, simply scaling the inputs, as discussed in the previous chapter, increase accuracy above 90%. From scikit-learn.preprocessing import standard scalar, scalar object equal to standard scalar class, xtrain scaled equal to scalar.fit underscore transform, x underscore train dot as a type mp.float 64. Cross validation score at GD classifier x underscore train underscore scaled y underscore train comma CV equal to 3 comma scoring equal to accuracy. This is the result. As you can see, the accuracy above than 90%. Thanks for watching.